Okay, this one is just too good not to share. I saw it and I immediately thought of all of you. So, let's go. So we have this picture here and the question is how many animals are in this picture? And if you were thinking this is an image processing problem, then you are absolutely right. Now, if you were thinking this is a computer vision problem, well, that is also correct. But I would say that this is actually a data science problem. Why? Well, because at the end of the day, this is really a statistics problem, and statistics is part of data science. Now, what kind of statistics problem, you may ask? Well, this is an example of a counting problem, specifically the problem of estimating the number of objects in an image. So yes, this is a machine learning problem, where you will have some labeled data, and you need to use a model which can learn from the past and make predictions about the future. So let me quickly show you an example. This is a training example. On the top left, we have the image itself, and then we have the actual number of animals. Then we have the predicted number of animals. Now notice how the more animals there are in the image, the more difficult it is for the model to predict the actual number. Why? Well, because as the number of objects increases, they start overlapping, and this makes it more difficult. This is similar to other areas like finance, for example, where it's very easy to detect edges when you have low noise, but when you have high noise, detecting edges becomes more difficult. Now, before we talk about how to solve this problem, let's think about how humans would do it. For humans, it's fairly simple. You just look at the image and count. But even for humans, this becomes more difficult as the number of animals increases. Why? Well, because, as the number of animals increases, they start overlapping, and this makes it more difficult to count them. There are several strategies that humans might use to deal with this problem. One strategy is to focus on one animal at a time and keep track of the count. Another strategy is to group together animals that are close to each other and then count the groups. Humans are smart enough to know when to use which strategy, and they can switch between the two as needed. They can also use other strategies like looking for patterns or using their knowledge of the world to help them count. Now that we've talked about how humans solve this problem, let's take a look at how machines can be trained to do it. The first step is to collect data. We need to collect a bunch of images of animals, and then we need to annotate these images with the actual number of animals in each image. This is the labeled data that we'll use to train our model. Once we have our data, we can start training our model. We'll feed the model some data, and then we'll tell it how far off it was from the actual number of animals. We'll repeat this process until the model is good at counting animals. There are a lot of different models that could be used to solve this problem. One popular model is called a convolutional neural network, or CNN. CNNs are really good at solving computer vision problems. In fact, they're the reason that computers can now beat humans at playing video games. Another model that could be used is called a recurrent neural network, or RNN. RNNs are really good at solving problems where the input data is sequential. For example, RNNs are often used to solve natural language processing problems. Now that we've talked about some of the models that could be used to solve this problem, let's take a look at the results. Here are the results for a CNN, and here are the results for an RNN. Both models were trained on the same data, and both models were able to learn how to count animals. The CNN was able to achieve an average mean squared error of 10.4. That's pretty good considering that the actual number of animals in the test set ranged from 1 to 20. The RNN was able to achieve an average mean squared error of 8.7, which is even better than the CNN. Now you might be wondering what these numbers actually mean. Mean squared error is a way of measuring how close the predictions of your model are to the actual values. The lower the mean squared error, the better. So, in this case, the CNN's predictions had an average mean squared error of 10.4. This means that the average squared difference between the predictions and the actual values was 10.4. So basically, the CNN's predictions were off by an average of about 3.2 animals. The RNN's predictions had an average mean squared error of 8.7, which means that the average squared difference between the predictions and the actual values was 8.7. So the RNN's predictions were only off by an average of about 2.9 animals. So that's how a machine can be trained to count animals in an image. It takes a lot of data and a lot of computing power, but it can be done. Now, once you've trained your model, you can use it to predict the number of animals in a new image. So, let's take a look at how well our model works on a new image. Here's an image of some animals and we want to know how many there are. We'll feed the image to our model and see what it predicts. The model predicts that there are 12 animals in the image. Let's compare this to the actual number of animals. There are actually 13 animals in the image. So our model was off by 1. That's pretty good considering the complexity of the image. Overall, our model does a pretty good job of counting animals in images. It's not perfect, but it's pretty close. This is an interesting problem, and I wanted to share it with you because it shows how data science can be used to solve real-world problems. It also shows how much progress has been made in the field of computer vision. Just a few years ago, it would have been very difficult to train a machine to count animals in an image. Today, it can be done. And finally, it shows how important statistics is to the field of data science. At the end of the day, this is really a statistics problem. Alright, so those were my thoughts. Thank you for watching and consider subscribing if you haven't yet. And I'll see you in the next video. Hi friends, welcome to my channel. And today we'll be talking about an introduction to data science and applied mathematics. So, this course is actually for everybody who wants to get into the field of data science, even if you are not from a technical background. Don't worry, because in this video I'm going to explain everything from scratch, so that even if you are from a non-technical background, you will be able to understand it. And after completing this course, you'll be able to apply for data scientist roles in any industry. Data science is all about digging into data to find valuable insights. It mixes science, algorithms, and methods to make sense of both structured and unstructured data. Think of it as using cool tools like machine learning to pull out the good stuff from all that information we have. It's pretty fascinating. So let's take a look at the different topics that we are going to cover in this course. In the first module, Introduction to Data Science, we will cover the definition of data science, the applications of data science, and then we will talk about the tools. And I got this question from a community member who is asking about the difference between the two courses: Data Science Foundations using RN Data Science and Applied Mathematics. So here I have opened up the course page for Data Science Foundations using RN. If I scroll down to the course description, I can see that it is an introduction to data science with lots of focus on the application of statistics and machine learning. And then here I have the other course page opened up, and if I scroll down to the course description here, we see that this one is also an introduction to data science, but this one is using Python as opposed to R, and this one also has more of a focus on mathematics and statistics rather than machine learning. So looking at these two courses, I think the main differences between them come down to 3 things. Which language you want to use, whether you want to focus more on statistics or machine learning, and then also what kind of math background you have. So let's take a closer look at each of these 3 things, and that should help you decide which of these 2 courses is going to be best for you. Okay, so the first thing was the language, and we already know that one course uses R and the other one uses Python. So just depending on your preference, you might lean towards one of these courses over the other. Now, personally, I'm biased because I really like both of these languages, but generally speaking, if you have no programming experience, then it might make sense to start with Python, because Python